2013 was a big year for Ames Research Center's space exploration programs, including several new launches and continuing a long history of cutting-edge innovations. Designed and built at Ames, the Lunar Atmosphere and Dust Environment Explorer, or LADEE mission, was successfully launched and sent to orbit the Moon to conduct science operations. The spacecraft is studying the extremely thin atmosphere or exosphere of the Moon and measuring the amount of dust found in this region of space. Ames is managing the science operations for the LADEE mission, as well as commanding and controlling the spacecraft using the Multi-Mission Operations Center. This facility is also being used by controllers for the Interface Region Imaging Spectrograph, or IRIS mission. The IRIS spacecraft successfully launched this year on its mission to study the region of space around the surface of the Sun. Using state-of-the-art imaging technologies, IRIS is gathering extremely high-resolution data about the energy release from the Sun that creates what is commonly referred to as space weather. The Kepler mission continues to make groundbreaking discoveries and redefine our understanding of planetary systems and stars in the galaxy. The team has found hundreds of new planet candidates this year and continues to discover smaller, Earth-sized planets orbiting in the habitable zone of their Sun-like stars. For Ames researchers, 2013 could be called the year of the nanosatellite. Several of these tiny satellites were built and sent into space, including the innovative PhoneSat CubeSat. PhoneSat was created as a technology demonstration mission to prove that a satellite based on a smartphone could function in space. This year, the team successfully flew 4 of the tiny satellites in space, and future versions are already in development. The TechEdSat CubeSat was also built at Ames as a technology demonstration. It tested a new exo-braking parachute system that could allow satellite payloads to safely re-enter the Earth's atmosphere. In collaboration with the Air Force, a team at Ames built the first nanosatellite launch adapter system. NLAS is designed to launch multiple CubeSats from rockets that could previously only carry 2 or 3 at a time. The Intelligent Robotics Group at NASA Ames is working to improve the capability, functionality, and reliability of robotic systems that are key to the future of space exploration. On 3 different occasions this year, astronauts on the International Space Station remotely operated the Ames-developed K-10 planetary rover located at the center's Marsscape. These tests were the first time an astronaut in space controlled a rover on a planetary surface. 2013 was also a year that Ames researchers conducted experiments on the International Space Station to better understand the effects of microgravity. Seedling Growth 1 was designed to study how plants respond and adapt to a range of low-gravity environments. The results of these studies could be key to supporting astronauts for long-duration space missions. Ames also developed the cell biology technology demonstration. The system is a simple yet highly effective method for conducting cell biology tests while in space. A team at Ames tested an innovative and compact heat shield that could expand like an umbrella to enable much larger payloads for planetary entry than are currently possible. Wind tunnel tests on models of the NASA Space Launch System were conducted at Ames to help improve the design and stability of NASA's next heavy launch vehicle. This summer, NASA launched Spaceloft 7 and Spaceloft 8, 2 suborbital rockets from Spaceport America near Las Cruces, New Mexico. They achieved a record altitude of 73.9 miles while carrying a variety of experiments in microgravity. Ames manages the selection and development of payloads for the suborbital flights program. The Curiosity rover continues to explore the surface of Mars, and a team from Ames is using their X-ray diffraction instrument called CheMin to analyze the soil and find out exactly what minerals it contains. Ames researcher David Blake developed the CheMin instrument that is one of the key tools being used to identify whether the conditions for life could have existed at one time on the surface of Mars. Using instruments on the Mars Reconnaissance Orbiter, researchers from Ames and JPL are working to see if a form of salty water is responsible for the seasonal slopes that appear on the sides of Martian hills and mountains, an area where scientists generally believe conditions to be dry. Researchers in Ames worked in partnership with the Russian Space Agency on a life science experiment called Bion-1. The mission was to study how life adapts to microgravity in space and then readapts to gravity on Earth. The Ames-developed Pioneer 11 spacecraft reached its 40th anniversary in space. Launched in April of 1973, Pioneer 11 flew past Jupiter and Saturn and collected tremendous amounts of data about both before communication with the spacecraft ended in 1995. As they did in 2013, scientists, researchers, and staff are hard at work to continue their mission to make new discoveries in 2014 and beyond.